Hi, in this video we're going to continue the objective of simplifying trig expressions using trig identities. And you can see how I copied, pasted the trig identity sheet so we can use it as we are simplifying. This video will include example 3 and example 4. In a previous video, we discussed example 1 and 2. So let's write example 3 and take a look at how we can simplify it. Cosine x over 1 minus sine and minus sine x over cosine x. And as you see, the word simplify comes with the word expression. A big misconception would be solve. We are not solving. We solve when we have an equation. So if this looked like an equation like equal 0, equal 1, equal cosine x, or equal any other value or expression, that would be solving. We are not solving because we just have an expression and we don't have an equation. Now, we take a look at this and we say, oh, how about we cross the cosines? I would have agreed with you if this was a multiplication, but it's not. It's a subtraction, so we're not allowed to simplify across. Another suggestion was, what if we cross multiply? So cosine and cosine, 1 minus sine with the sine. Also, I would have agreed with you if this was an equal sign, but it's not. It's a subtraction. So both suggested methods aren't correct, aren't algebraically correct. So I see we're subtracting, and we are more specifically subtracting fractions. So the first thing that should come to our mind is a common denominator. Let's take an example with numbers. 3/4 minus 1/5. We are subtracting fractions. What do we need to subtract fractions? We need a common denominator. I look at 4 and 5 and there's nothing in common. So I multiply 4 by 5 and I multiply 5 by 4 to get a common denominator of 20. Whatever I do on the denominator, I must do on the numerator. Similarly, when I look at this, I would say cosine x, I have to multiply it by the first denominator, which is 1 minus sine. And the 1 minus sine, I have to multiply it by the second denominator, which is cosine. That way, I can get a common denominator, which is cosine x, parentheses, 1 minus sine. Extra parentheses never hurt. And whatever I do on the bottom, I must do on top. So I'm going to do the same exact thing. Cosine times cosine is equal to cosine squared of x. You might think in two different ways. Should I write this or should I write that? Is it cosine of x squared? Or is it cosine squared of x? And actually, it's cosine squared because cosine multiplied by cosine is cosine squared. Minus, we're going to have to distribute the negative sometime, so don't forget about it. Sine times 1 is equal to sine. There's a negative right here. And sine times sine is sine squared of x, but we can see that a negative multiplied by a negative will turn into a positive. So how does this help? It actually helps because we can see one of the trig identities right here. Sine squared plus cosine squared is identity 9, which equals to 1, Pythagorean identity. You might tell me it's in a different order or they're far apart. That's totally fine because it's addition subtraction. Let's say we had 2 minus 3 plus 8. I can simply rearrange that into 2 plus 8 minus 3. 8 plus 2 minus 3. So I can rearrange it And I can see that according to identity 9, this is equal, the highlighted will give me 1. And I'm just going to copy everything else. So 1 minus sine x over cosine x, parentheses 1 minus sine. And if I look now, I can see that this is a common factor, 1 minus sine and 1 minus sine. Can I cross them out? Yes, because you can add a 1 right here multiplied by this. That's not going to change anything. And that helps me visualize how I can simplify. So 1 minus sine are gone. And this expression would simplify to 1 over cosine. Some of you might ask, why not writing it as secant x? Because 1 over cosine, as we see right here, cosine is 1 over secant, and we can see that secant is 1 over cosine. You can, but you don't have to, and preferably don't do it. Especially when we say simplify the trig expression, we want to make sure we go back to cosine and sine, which we call them the basic trig functions, the building blocks. Anything else is made of those building blocks, secant, cosecant. In the book, you're going to see the question like simplify trig expressions using basic trig functions, and those are the basic. So example 4, the challenge with this objective is that every example is different. There's no one way to start simplifying. You're just going to use your algebraic skills. You're going to get used to it with a lot of practice. Example 1, we factored. Example 2, we distributed first. Example 3, we made the common denominator. And now let's look at example 4. When I see a negative right here, that reminds me of even and odd identities. So I look at even and odd identities, and I look at cosine of negative theta, which is identity 20, equals to cosine of theta. So cosine of negative x is equal to cosine of x. And again, this is identity 20. I do want you in the homework practice problems, page 410, 9 through 22, to write down which identities you're using. And one of the questions was, could we use multiple identities in one problem? Definitely. Use as many as you want so it can help you simplify it. Cosine x minus cosine x, it's the same exact quantity, one time positive, one time negative, and that equals to 0. So now it's your turn to practice page 410, number 9 through 20.